Hey, welcome to blacksandwhite.com. In this video, we will learn about important data structures: array, linked list, graph, queue, tree, stack, and hash table. Array. An array is a collection of items stored at contiguous memory locations. The idea is to store multiple items of the same type together. As you can see in the diagram, the array is shown with elements like 5, 15, 25, 35, 45, and 55. Each element is placed next to each other in memory blocks, such as 200, 206, 207, 208, 209, and 211. Every element in an array has an index number. The index starts from 0 and goes upward, so the first element is at index 0, the second at index 1, and so on. This indexing allows us to directly access any element quickly. To understand better, think about cars parked in a single straight line. Each car has a fixed position in that row, just like array elements in memory. This is why arrays are considered one of the simplest and most efficient ways to store data in programming. Linked list. A linked list is a linear data structure where elements aren't stored next to each other in memory. Instead, it's a chain of individual units called nodes. Think of a node like a small box with two sections. The first section holds the data, and the second section contains the address, which is a link or pointer to the next node. You can visualize this like a train, where each car is a node, and the coupling is the link connecting it to the next car. This structure allows us to link data together in a series, just like the example shown where 10 points to 20, which points to 30, and so on. This makes it a very flexible way to organize information. So, a linked list is simply a collection of nodes, and each node has two paths, data and an address that connects it to the next node. Let's understand what a graph. A graph is a nonlinear data structure consisting of vertices and edges. The vertices are sometimes also referred to as nodes, and the edges are lines or arcs that connect any two nodes in the graph. Let's understand this with the diagram. We see several circles, labeled A, B, C, D, and A. These are called vertices or nodes. They represent the main points in our graph. Now, let's look at the lines connecting them. These are called edges. An edge represents a relationship between any two nodes. For example, the line connecting A to B is an edge. Notice how the label points directly to B, showing that it's a node. The small circle with an arrow on node C is called a loop. This means C has a connection that starts and ends on itself. The arrows on some of the edges show the direction of the relationship. The arrow from A to B means the connection goes one way, from A to B. A great real-world example of a graph is a spider web. The points where the silk threads meet are the nodes, and the threads themselves are the edges. In short, a graph is a set of nodes and the edges that connect them. Let's learn about queues. A queue is defined as a linear data structure which is open at both ends and the operations are performed in first out, FIFO, order. The element which is first pushed into order, the operation is first performed on that. Let's look at the diagram. We have a queue with 5 items. The front of the queue is called the front, where items are removed. The back is called the rear, where new items are added. The two main operations are enqueue and dequeue. Enqueue is the operation of adding a new item to the rear of the queue. For example, the number 6 would be added after 5. Dequeue is the operation of removing an item from the front. The number 1 would be the next item to be removed. A perfect real-world example is people waiting in a line. The person who gets in line first is the first person to be served and leave the line. This is exactly how a queue works. Tree data structure. A tree is a nonlinear hierarchical data structure that consists of nodes connected by edges. A node is an entity that contains a key or value in a pointer to its child nodes. Let's look at the diagram. At the very top, we have the root node, labeled P. This is the starting point of the tree. The nodes directly connected below it, like Q and R, are its children. P is the parent of Q and R. Nodes at the same level, like Q and R, are called siblings. The nodes at the very bottom, such as A, F, G, H, and I, which have no children, are called leaf nodes. A section of the tree that can be considered a smaller tree itself is a subtree. The total number of levels from the root to the farthest leaf is the height of the tree. A great real-world example is a human family tree, where each person represents a node, and the relationships are the edges connecting them. Let's see stack. Stack is a linear data structure that follows a particular order in which the operations are performed. The order may be LIFO, last in first out, or FIFO, first in last out. Push operation. The diagram shows adding a new data element to the top of the stack. Each push increases the stack's size, always placing the new element above existing stored items. Stack after push. After pushing, the stack grows taller, holding multiple elements. The latest element stays at the top, meaning it will be the first one removed when pop is performed. Pop operation. Pop removes the topmost element from the stack. The arrow indicates removal, ensuring that the most recently added item is always the one taken out first. Real-life example, plates. The plate stack demonstrates stacks. Plates are added from the top and removed from the top only. This mirrors LIFO principle where last placed is first removed. Hash table. A hash table is a data structure that stores data in an associative manner. In a hash table, data is stored in an array format, where each data value has its own unique index value. Keys like Raj, Golu, Aryan, Chandan represent unique identifiers. In hash tables, these keys are inputs used to quickly locate and retrieve corresponding values stored in memory efficiently. The hash function converts each key into a specific index number. It ensures mapping from variable length keys into fixed size values, providing direct access positions inside the storage table. Storage is an array of slots, 0005. Each index stores data values. After hashing, keys are assigned to these slots, making search and retrieval fast, constant time operations. Example, file drawer. The drawer example shows organization. Each file has its own index position. Instead of searching entire data, you directly open the specific drawer, just like hash table indexing. Thank you for watching. We hope you understood the concepts of stack and hash table clearly. Keep learning, keep practicing, and apply these data structures in real-world problems. For more, visit www.blacksandwhite.com.